Hi everyone. In this video, we are going to discuss this exact differential equation. Getting? In previous video, we have seen several examples of exact differential equation, but this is one more interesting exact differential equation. So let us see how to solve this one. Okay. So before starting the actual solution, we will revise few concepts and then we will move further. So the equation m dx plus n dy. Okay, so if you have any differential equation in this form, so when we can say it is exact, if derivative of m with respect to y is equal to derivative of n with respect to x. Partial derivative of m with respect to y must be same as partial derivative of n with respect to x. If both partial derivatives are equal, we declare the given differential equation is exact. Now the question is how to solve. So it has fixed solution. Okay. So simply in a solution, we have two integrals. We add them and is equal to c. That will be the answer. Those two integrals are integration m treating y constant dx. So we are integrating m with respect to x, but we are considering y constant, plus integration terms in n free from x dy is equal to c. So in second integral, what we do, if you have any terms of x in n, we remove them and we simply consider those terms of n which are free from x. There should not be any x. Those should be the function of y only. Getting? We add the values of these two integrals and we write is equal to c. That will be the solution. Okay, so this is our method. We are going to follow it to solve this given differential equation. Okay, so let us focus on this format: m dx plus n dy. M and n both are functions of x and y. Multiple of dx is our m. See, you can see in a given differential equation also, I have written that thing already, so I will not rewrite. So multiple of dx, so you can see this bracket is a multiple of dx, so this is our m. Multiple of dy, so multiple of dy is a second bracket, so this is our n. So let me note down our m and n first. We have our m is 2xy cos x square minus 2xy plus 1, n which is multiple of dy sin x square minus x square. This is our n, right? So our next task is to check whether these partial derivatives are equal or not. So let us start to find partial derivatives. First of all, I will find derivative of m with respect to y. Now, derivative of m with respect to y. What is my m? Let me put it here. My m is this entire bracket, 2xy cos x square minus 2xy plus 1. But as you can see, there are three different terms. First term, second term, third term. So if you have addition, subtraction, we take the separate derivatives. I will do the same thing here. So this is equal to derivative of 2xy cos x square minus derivative of 2xy plus derivative of 1. After that, what will I do? We are differentiating with respect to y. So if there are any constants, we take them outside. As well as if there are any terms of x, those are also constant for us since we are differentiating with respect to y. So constant as well as functions of x, I will take them outside since all of them are constant. 2 will come outside. X is also constant here since we are differentiating with respect to y. This cos x square, that is also constant. So inside the bracket, we have simply y minus. What will happen here? 2 and x both are constant. I'm taking them outside. So inside the bracket 1, y only. Derivative of 1 is 0. Since 1 is constant, derivative will be 0. What is derivative of y with respect to y? It is 1. And same thing will happen here. Derivative of y with respect to y, 1. So 2x cos x square into 1 minus 2x into 1 2x cos x square into 1 you will get same, minus 2x into 1, 2x. So finally we got the value of deba m by deba y. Now we have to focus on deba n by deba x, and we have to check whether both of them are equal or not. If both of them are equal, then only we can say it is exact differential equation. Okay. See, we have this space, let us use. Now consider deba n by deba x. I am differentiating n with respect to x. Okay, what is my n? Let me see. This is my n, sine x square minus x square, sine x square minus x square. But as you can see, there are two different terms. Getting sine x square first term, x square is second term. Both of them are separated by this minus sign. So in case of derivative, if we have two different terms and they are separated by plus or minus signs, we take separate derivatives. So derivative of sine x square minus derivative of x square. Okay, so let me remove this part. Okay, so we will have some more space to write. I hope you have understood what we have to do. Okay, so yes, let us remove. So we have to find the derivative. Okay, so as you can see here, inside the sign we have a x square, but no need to worry about it getting. So we have to focus only on outer function first. The outer function is sine, and inside the sign we have x square. So let us find derivative of outer function first. What is derivative of sine? Cos. So it will be cos, whatever inside sine I should copy as it is getting. So derivative of sine x square is cos x square. So simply we found out the value of outer function getting. So after that we have to take the derivative of inner function also. So derivative of x square now. Understood now? So this is called chain rule. Whatever the outer function, we find its derivative first, we write the inner function as it is, then we will go further and we will find the derivative of inner function also, minus. The next is derivative of x square. What is derivative of x square? Are you familiar with this formula? Let me write here. So derivative of x raised to n is n x raised to n minus 1. This is very simple formula. Whatever the power we have, we write it before x. We reduce the power by 1. So what will happen here? The power is 2. 2 will come further, we reduce the power by 1. So that means 1 only. So using this formula, I got the derivative to x only. So cos x square. Same thing we have. So its derivative will be again 2x minus 2x. So let me write this 2x first. 2x cos x square minus 2x. So let us check both of them are same or not. Yes, both of them are same. 2x cos x square minus 2x, 2x cos x square minus 2x. So therefore deba m by deba y is same as deba n by deba x. So that condition is satisfied. So we can say it is exact differential equation. So let me mention here. Therefore, it is an exact differential equation. So we proved it is exact differential equation. That means now we can use that method to find its solution. Okay, so you remember there are two integrals. Okay, so we cannot solve both integrals simultaneously. I will find the value of first integral first, and then I will go for the second integral. So what is the first integral? Consider the first is integration m treating y constant. Okay, and with respect to x. So let me write what is my m. My m is this one, 2xy cos x square minus 2xy plus 1. Okay, and we have here dx. We are integrating with respect to x. You can see there are three different terms, first, second, third. Both are all are separated by plus minus sign. So I will take separate integrations. So integration 2xy cos x square dx minus integration 2xy dx plus 1 dx. That means you can simply write dx. Okay, so there is no more space to write. Make a screenshot of it first. Okay, and then we will move further. So now let us take constants outside. Okay, let us find what are constant here. Is equal to 2 is constant. Y is also constant, since we have already mentioned y is a constant. So 2y will come outside integration x cos x square dx. Okay. In second integral, 2 and y both of them are constant. So let me write minus 2y inside integration x dx. Am I right? X dx. Integration of dx is x only, right? Yes. So it is looking quite difficult, but see, let us solve this integration first. Okay. So what will I do? 2y integration x cos x square dx minus 2y. Integration of x is x square by 2. Okay. So let me tell you which formula I am using here. The formula is integration of x raised to n is x raised to n plus 1 upon n plus 1. So this is very simple formula. If you have x raised to n, okay, that type of function if you have, simply we increase its power by 1 and the same number we write in denominator. So initially its power was 1, right? 1. So I increased it by 1, so it became 2, and the same number I wrote in denominator. So 2. Get it? So let us move further. Plus x as it is. So as you can easily see, 2 2 we can definitely cancel. 2 2. Let me repeat. Okay. But still we are facing problem getting in first integral. We haven't solved this first integration yet. Since x is there and inside the bracket we have x square, so I think that the regular formula will not work here. We need to go for the substitution. Okay, we need to put something so it can solve easily. So generally what we put, whatever inside the bracket we have, or whatever, if you have something different in power, generally we put that thing here. So here inside the bracket we have x square, so I am going to put that x square is equal to t. Putting x square is equal to t. I am putting only in first integral, remaining part will be same. See, when you put anything, the first task is to find the derivative. Getting? So derivative of x square is 2x. We are differentiating with respect to x, and derivative of t will be dt by x. I am differentiating with respect to x. Its derivative is 2x. Derivative of t is dt by x. Let us shift dx on this side. So 2x dx is equal to dt. Clear? 2x dx is equal to dt. See, we have this 2x dx. So therefore, let me write integration m dx. Okay, m dx is equal to, let me show you. We have this 2, we have this x, we have this dx. 2x dx, 2x dx. These three terms can be replaced by a single term dt. You are getting the point? So maybe you are thinking this 2 is outside the integration. So how can we take with x? No need to worry, since 2 is a constant. It can go outside, it can come inside, it's a constant. Okay, it can free to move anywhere. See, so that's why 2x dx, this term is replaced by dt. Let us think about the remaining terms. Y integration, y is still there, cos x square. X square is t, it means we will have cos t, and 2x dx, these three terms are replaced by dt minus y square. Okay, so x square y plus x. Do you remember the formula of integration of cos t? Cos t integration is sin t. Sin t. Okay, so sin t minus x square y plus x. That's it. But see, that variable t we have taken, it is not a given variable. So we need to resubstitute its value. Its value is x square. So let me put it here. So y sine x square minus x square y plus x. That's it. So in this way we solved the first integral. Getting? So still second integration is there, we need to solve. At the end we will add them and is equal to, see, that will be the answer, right? So make a screenshot of it first, then we will move further. So what is the second integration? Let us see. Okay, the second integration is, let me write, now consider integration terms in n free from x dy, right? So terms in n free from x. Okay, so let us see first what is my n. Let me write here, our n is sine x square minus x square. You can see there are two terms, right? See, there are two terms. So this is first term and this is second term. So but we want the terms free from x. Here in the first term we have x, so we cannot take the first term. As well as in second term also we have x, so we cannot take the second term. It means we cannot take both terms, getting? So that means only 0 will be there since both term contains x. So we cannot take here. Since free from x we want, integration of 0 is 0. So therefore, solution is, you know the solution, okay? I have already told you. Solution is sum of these two, value of these two integrals. The value of first integral is y sine x square minus x square y plus x. So this is value of first integral, right? Second integral is 0. So plus 0 is equal to c. So y sine x square minus x square y plus x, if you add 0 you will get same, is equal to c. So this is required solution. So in this way we got the solution of given differential equation. Okay, so make a screenshot of it, then we will stop. Thank you. See you in next video.